guess we'll get started then. I'll obviously, you can hopefully you've been able to grab slides and other stuff if you'd like. This is hopefully what you're seeing, but these first three files are basically the things that you'd be working with today if you want to code along, but the actual presentation is this final HTML file if you also just want to use it for your own records. So thanks for coming. It's really nice to be able to talk to this stuff. As I slide says, I've become annoying about R, but I love it, and I'll talk about why I think it's really important as growing into graduate school and that kind of stuff. Oh, by the way, I've been giving versions of the slides. Clearly, it's like misstated. I'm giving versions of this for a long time, so that's why. So if you have any comments and feedback, I'm obviously looking for those because I update these slides quite often. Okay, so just for some sort of outline of what we're hopefully going to be able to talk about today, a little bit about me, why I love this thing, why R in general, and then learning how to do it. I feel like that is actually the biggest hurdle. Most people can, it's not that hard, but the process of learning it is, I feel like, a weird barrier that people don't talk about. So talk a little bit about how you get up to speed and integrate it as part of your research. And then a little bit at the end will actually be like the basics of the language and how to use it. Okay. So just a little bit about me, background. So I'm a postdoc right now with Brian Levine at Baycrest. I did my PhD at Waterloo. I'm a Waterloo lifer. Like I did 10 years there because I did my undergrad, master's, and PhD there. So if you ever have questions about that school, I love it too. I am almost entirely self-taught. Sorry, is it? Okay. I'm also very soft-spoken. I did a regular old like psychology background. All of my undergrad was in psychology and then cognitive neuroscience for all of my graduate work. And at University of Waterloo, loved them very much, but I was taught entirely in SPSS. That's just what I was exposed to. That was how I was graded. So in order to switch to R, I had to teach myself basically everything, which I have to say, if I can do it, then anyone can really. I do not have the aptitude for R or coding or anything. I just happen to take it up. So if you feel like a lot of people don't identify with coding or R or that kind of thing, just know that you do not have to be a programmer to program. And I also did it pretty late. So people look at me and I do sort of computational work. It's a lot of my research, but I actually picked it up quite late. So it's never too late to learn new tricks. Okay, so because you're here, hopefully I don't have to actually, convince you very much, but I think there are lots of upsides to using R. The biggest one being that it saves a lot of time and energy. Oh, I just noticed I can full screen that. This is a random picture I found on Reddit whenever it was popular, and so this was on the front page, and so it was like, oh, this was me in third and fourth year undergrad with 10 different screens open because one of them has my data, one of them has my analysis script, one of them has my edited data, one of them has. So it's an absolutely insane thing to be doing at 8 p.m. on a Friday because you have your honors thesis to write or something. So once I started working with R, it was basically the first time I felt like I was in control of what I was doing. Everything I was sort of manually doing, switching between programs and SPSS and all that, felt like I was really just being blown around by whatever SPSS wanted me to do. So all of this goes away once you start working with R. You do not have to keep like switching between your Excel to syntax to actual SPSS, whatever. So get rid of all of this. Finally, there's a lot of stuff obviously related to BrainHack that you just can't do with, even SPSS, Jamovi, JASP, all of that. So if you want to start doing more complicated stuff, you have to start at least being okay with code. Of course, this is sort of self-explanatory. If you want a job, it's much easier to say that you are fluent in a language that is actually used in that job as opposed to something that is point and click. Okay, so the process of learning R. I feel like most people want to learn it, but there's very little actual advice of how to do it. When I started to switch, I basically had one person tell me just, quit cold turkey and then you can pick it up. But I don't think that's like the most helpful thing. One piece of advice that I always tell people is that you have to start changing behaviors and choose it over the alternatives. So the only thing that actually worked for me was basically a worldwide catastrophe. COVID hit, and I physically did not have access to a computer with SPSS on it anymore. And so I had to tell myself, well, if this doesn't get me to be comfortable with R, then nothing will. So honestly, when I say that you can pick it up, you do need to sort of change your habits. If you are still picking up SPSS and Jamovi and JASP as your first line of defense, you will probably not become fluent with this thing. You do have to choose it. But there are some strategies that I do recommend if you are trying to become more fluent. So the first thing is that it helps to have a community. If you're learning alongside with others, it's much easier. You can pass things along. That's why we bring people together for something like BrainHack. You can debug together, you can commiserate about your errors together. You can just see that it's not that easy when you're together. So I strongly recommend finding other people, even if they are not at the same level. When I first started, I found like a senior graduate student who was much more advanced than I, and basically learned from all of her scripts. So find other people. Do not be worried about where you get your information. If it exists on the internet, use it. That's the point. People sometimes feel like, oh, to program, I just need to like have the syntax in my head. And in some ways you do learn those, but it's just you getting better at programming means getting better at Googling about programming. So use the resources at your behest. It's what all good programmers do. They don't memorize, they just know how to search for things well. Okay, the other thing is that when you first start, you get a lot of errors, and that is a big switch to turn in your brain. A lot of people, it feels like R is screaming at you when you get an error, but it's progress. It all is. Getting a new error is progress. So know that it will happen, and you're going to have to figure out emotionally how to deal with it. It's a new frustration that most people haven't experienced before in their lives. So just know that it is emotional, and you're going to have to power through it. That's why I say always be kind to yourself. You're learning a new language, you're learning a really important skill. So just know that everyone goes through something that is unique and often difficult. So allow yourself some grace. Okay. Any questions so far? Okay, awesome. So, okay, nuts and bolts actual R stuff. I'm going to start from the very beginning. So obviously tune me out if you're not at this stage, but I have often find out, I still learn things about all of this stuff all the time. So who knows, I might surprise you. Okay, so very bare bones stuff. What is R and RStudio? So R technically is the language. joke about sometimes I have like research assistants who come, it's like, oh, she's great at RStudio. And like, well, sure, the language is R. So when you're doing it, that's the language. It's been free and open source since 1995, which explains a lot of why the community is the way it is. So it's very widely supported. It's not going to disappear overnight. And basically, there's this worldwide community that really wants to open source things because languages. So all of these great resources, which I'll have links to at the end, are all generally made open because it just attracts this environment where people want to be releasing things for free. So that's a big plus. RStudio is generally one of the more popular IDEs or integrated development environments. It's the software. You can run R code using RStudio. It's technically owned by now Posit. It's in this weird transition space. So if you see the word Posit, it is the company that develops RStudio, but they're actually trying to, this is neither here nor there, but they're trying to debrand away from R because technically you can write in Python in RStudio, like an R markdown script, you can switch to Python in any chunk. So they're actually developing a new program called Positron. If you see that, it's related, but I'll be talking about RStudio because I still use that and I do recommend it still. Okay, so chances are if you've used RStudio, you're very familiar with this image, but I do want to sort of point out a couple of things that people are not necessarily aware of. So when I have sort of students that I'm just showing, okay, this is how you run your first script, usually they're a little confused as to just orienting themselves. So up here in the top left is what they call the source pane, and this is where you're going to do most of your actual like activity on R. So this is where, so for example, this person seems to have launched an R script to the .r, which I'll explain in a moment. But it shows up as a tab, just like any other browser. It pops into here, and all R scripts are text. And so when you are running R code, it is this text, and you would say that there's like a big play button here that you would click, and that runs the code in this top section. So if you're editing your scripts, it's up here. And you can save it and everything, just like any other sort of browser or Word text editor, that kind of stuff. So operating up here is where your script is. On the top right here is the environment pane, and this is basically where everything gets stored when you're interacting in this project. So for example, we'll talk about creating objects and that kind of stuff. When you are executing script, you can save little objects that don't exist on your actual like hard drive computer. Those objects are temporary and they live in this imaginary environment over here. So for example, if you want to store just a variable for your function or something, you're doing some quick math, you store it as an object, it appears here, but doesn't land anywhere like on your computer. So if you want to inspect, oh, I think I saved an object, where is it? It would be over here in your environment, okay? Why don't we go down here? So this one is called the output pane, and this is generally where, as it suggests, as the output when you're like creating things like a plot, that's the default of where it'll show up. But also down here is a little really helpful tab that, called the Help tab, and I'll be talking about it later. But for example, if you're not sure what a function does, or you're not sure what this package includes, this is where sort of most of that thing would appear, and you can search it just like any search engine, except it's going directly to whatever the creator's documentation is. So you don't need to Google, you can actually find the original writer's like explanation of what this function is just by going to that Help tab. Okay, and down here is the console. Here's where you would basically talk directly to your computer. technically everything that you run in this tab, if you're running the scripts, those also are talking to your computer, but this is if you want to execute some amount of script without actually changing a script file. So if I quickly wanted to just say, well, I can ask here oh, I don't know what this function does, but I don't need to add it to my script, asking for help. So if I ask for help, I can just do it quickly in the console and then it'll pop out here. So most people, especially when they're starting with R, don't really use the console down here, but just want to point it out. So focusing on the top left. Okay, so file types. I talked about that .r file as an example here. Oh, yeah, I'm perfect. That's right at the start. This is basically the default, what you might have seen or gotten passed around to you in classes or something. A .r script is basically just plain text, right? So you could write an R script in, Microsoft Word. You could write it in Notepad or whatever. It doesn't actually matter because it's just text on text on text. It's nothing magical, but it's contained at this .r just so R recognizes it and sort of that it's code. Okay. The reason why we generally don't work with .r scripts anymore is that number one, you can only really include R code. You can obviously include comments, but I'll explain why this can be a little limiting. And the other thing is that it always runs from top to bottom. So you can't really put breaks in between. If there's an error 98% of the way down the script, then the entire thing flushes. It goes, what's wrong? Something is wrong. I can't do this. So if you have very long scripts and it fails somewhere at the very end, you have to go through this long iterative process of figuring things out instead of sort of breaking things up into little digestible sections. So we've generally moved away from these to what you might see are R markdown files, .rmd. And these allow you to combine a couple of things. So both R code along with markdown. Just curious, has anybody here heard of markdown just as a language? Okay, lightly, that's good. So if you're editing Wikipedia or something, that's written in markdown. It's just a decorative language for producing visually appealing text. It's not really functional the way that R code is. It's doing a thing. Markdown is just a way of front-end development, making tables and lists. So the R code is quarantined to little sections that are actually functional, and then everything around it is markdown. You can just write your essay, your Wikipedia article right next to it. So that's why it's beneficial. You can run little chunks instead of having to run the entire thing top to bottom. So the slight upgrade recently that I'm talking about now, and I do the file that I did send you as the little example is a QMD. It's technically called a Quarto markdown. Now I'm also curious, has anybody here heard of Quarto or a Quarto markdown? No, good. Okay, so that's it's quite new, and it has a couple of upgrades that are functional. But the good thing is that it's backwards compatible. So basically, any RMD, you can just change the ending, literally manually change it. Okay, .qmd instead, and it will function. Same thing with a QMD. You can change it to a .rmd, and it'll do the exact same thing because it's text on text. It doesn't actually matter. But the point of a Quarto markdown, I do recommend upgrading to this version, is basically you can export a whole bunch of cool stuff, so more output types. This presentation is made in Quarto, and all I had to do was click a button and say, I'd like it to be a presentation, please. So you can do a lot of cool things. But basically, if you're working with just straight RMDs, it doesn't matter. You can switch it back and forth if you'd like, but I just recommend starting with QMD because it's the sort of where people are thinking R is going to move forwards. Okay, I also want to shout out that most people don't, at least when they're starting, don't know about the .rproj files. It's kind of cryptic what it is. It's called an R project file. And when you open it, so I gave you I gave you one in the zip sort of as an example. When you open it, it doesn't do anything, or at least it doesn't look like it's doing anything. You double click it and like it boots up R, but it's empty, and so people get confused as to what it is and why it's useful. It containerizes basically what you're doing. Maybe container is the wrong word because we're working with Docker, but it keeps things together. It logs sort of where you are in your computer, whereas sort of if you're working with a loose like .r script, you have to tell it, okay, start from here and don't go anywhere else because then you won't know where my data files, or you'll output it in some random file in the netherworld. So an R project basically says, okay, if you boot up this this first and then all of your scripts, it will know. So, okay, these scripts are all together. The next time you open that R project, it will boot up that same script that you last had in it. It will know sort of what was in the environment if you save it there. It will also like know sort of what packages are working with. It's just a good way to keep things organized in a way that if you're just working with a .r, for example, or just working with a .qmd, say you're working on one project and then you boot up your next QMD, it'll load into the same environment. And so if you have clashing names, suddenly you're working with a random data set and introducing variables that are from like an entirely different project and you didn't realize. So it just makes it so you are less likely to come into sort of human error. No, that's a great, yeah, I hope people have finished the Git meeting because it's very useful and yeah, it does a similar thing. Yeah. Right. Sorry. Yeah. Mm. Yeah. 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 It'll throw errors, and so it just makes it. So yeah, the R project doesn't have any data in it. Like it just like it sets like the direct, or like it knows where it is, like it knows where the file is, and so everything is relative to it. It basically puts a little pointer saying like, oh, my file is here, so look over here to the left, but it doesn't say like, oh, what the data is to the left. It just says it should be over there. So you don't need to put any data in the R project file. Ignore, yeah. Mm. So, oh yeah, just a couple of steps in case you're like not sure how to start. Usually when I'm starting a project or a code thing, you just go to File, New Project. You can choose either a new or existing directory. Directory just means folder, repository. They all repo. They all mean the same thing. So then usually I select Quarto project, but again, it's the exact same thing as like a RMD, R Markdown project. And yeah, as Aaron mentioned, you can just click this little button to get a Git repo for that. That's very convenient. Also, renv, if you see that, it's also a way of, it's like Conda of a way of managing your packages. So if you upgrade to a new package, you don't suddenly like crash your other projects that have been like there for 5 years. Okay. Okay, so when you're writing your first script, there's this cryptic thing at the top that I do want to talk about. It's always at the very start, and it's kind of hard to explain because YAML is not an acronym as far as I'm aware. It's like a backronym. Like YAML is not a markup language, something like that. Like people came up with something afterwards, but basically it's this the 3 dashes and then a bunch of actual functional code that is at the top of your R script, R Markdown and QMD. As far as I'm aware, they don't use in .rs, but anyways, the point of it is that it sets a whole bunch of options and metadata for the script file, so it helps you just label things. So like, for example, if I'll show you afterwards how I like export it to an HTML file. So if I send it to collaborators, it'll just say, oh, this is the file name, sort of just random decorative stuff, but also a lot of functional stuff. So I actually want my collaborators to see my code. So I set a thing so they can read it, and I want them to see my data frames. They can click through it. So it's useful. Just wanted to point it out at the top. You don't really need to customize this kind of stuff, especially when you're just starting out, but I just want to explain what this thing is at the top of your script. Okay, so it sets some options. Yeah, that's where a lot of the functional stuff happens. So the actual functional bit of the code. So everything that runs and actually does a thing is inside of a chunk inside of either your R Markdown or Corel Markdown. I'll just say Markdown from now on. I mean both. So everything lives inside of code chunks, and chunk is actually the technical term. And how they set what a chunk is between fences. So there's 3 tildes, and then the curly brace and this stuff is always the start of the first fence, and then 3 tildes at the end to end a fence. So everything within the fences is one chunk. And so in your R Markdown or Core Markdown, there's like a little play button next to here. And so you click it and it'd run everything exactly within these chunks. Okay. So you're basically telling it here with the little R at the start that this is R code. Then everything after is a comment. It's non-functional. So everything after the language, so you could put Python here, I believe, and it would potentially work. You might have to do extra things with your computer, but the rest of it is all decorative, and I do recommend naming your chunks. It's just helpful for you, and we'll talk about like good habits of labeling stuff. So R space anything non-functional, just labeling. Okay, so those are your fences. And then when you print something, when you run the code, it goes front to back exactly within this chunk, nothing else. Okay, so a couple of random shortcuts. I'll just have this spaced out wherever, but basically when I first started, I was like typing tilde, tilde, tilde. So don't do that. There are shortcuts. It'll make your life so much easier. Okay, so the next bit is also the sort of pound symbol with a pipe. So this is unfortunate lingo, but the straight up and down slash is technically called pipe, but we'll be talking about pipes later. This will be very confusing because the pipe one symbol is not the same thing as what we're going to talk about later, which are like functional pipes. But the point is this line plus the pound symbol sets options for this chunk. So for example, I don't want it to output something, or in this case, just for visual presentations, I want to highlight this line or something. So this can set, like if you're making a plot, I want it to be this wide. If I want, do I want my code to be hidden afterwards because it's not important? You just set them in these little things, and it changes the properties of this one chunk. Oh, this one chunk and nothing else. Wrong button. Let's try. Where is it? Oh, yeah. Okay. Here we are. So back to here. So the very first chunk in basically any logical markdown script is called the setup chunk. And I probably have to revise something that I said at the start, but basically the very first one is usually called r space setup. And this is the only instance in which naming a chunk is actually functional. So as I said earlier, basically, whenever you're naming, you're just naming it for fun for yourself, or you giving yourself the gift of knowledge in the future. If you name a single chunk exactly setup and nothing else, so this would actually not work because I called the setup example. But if I call it just setup, basically it will run anytime at the start. So if I run like the 50th chunk and nothing else, it will run the setup chunk first and then the 50th. Okay, so basically why this is helpful is, or why people use it is because when you load packages, which I'll explain in a second, these tell R sort of how to do a bunch of like pre-written tasks. So it's useful to have this setup chunk at the start that tells you that loads all these packages before you run something at the end. But it'll become clear why this is more helpful later. Oh gosh, I keep doing that. So let's go back. Okay. So you could use R as a fancy calculator. It will do what you are telling it. You're basically executing little math bits for ad infinitum. And so if you run a simple chunk like this, it will just print your answer, right? But the magic of R is that you're working with consecutively more complicated things. And so you get to define what you want and what you want to keep and what you want to operate on. So the core sort of loop of working with R is being able to create variables and then sequentially operating on them in more and more sort of complex ways. So this here, the left arrow-y thing, so a less than sign and then a dash, this is the assignment operator. And in R, when you assign something, so you have some amount of code after the assignment, and then you're assigning it to whatever you have before, okay? And I need to figure out what that is. I keep clicking something that sends me to the beginning. Okay, there we go. So what this says is that you're running the code and then you're assigning whatever the output is of this right-hand side. You're assigning it to this object. Okay, and you can name it whatever you want. It's just text. So I could name it here just my object. You can name it the object, a object. R does not care. So ideally, when you're creating objects like this, you're naming things, useful things for yourself in the future. Okay. As you'll notice, it doesn't sort of produce anything anymore. This is, you would run this and it gives you no feedback and you go, uh-oh, my R is doing something weird. And no, it's because when you assign something by default, it just assigns it. It would exist sort of in your top right environment. If you actually want to print it, you would have to actually call on the object. And when you call on it, it prints it by default. Okay. So in order to, by default here, if you're not assigning it, it'll just spit out whatever the output is. But if you store it as something, it will just store it. So the computer is doing exactly what you told it to, which is just leave it in as this object. If you want to read it out again, you actually have to call it. Okay. Another shortcut just for writing out that assignment operator. Okay, a quick tip also, if you want to both assign and print something, you can just use these parentheses around whatever you're doing, and then it will both assign it to that object, and then it will also print it within the same line. It's just faster. Okay, and then, as I mentioned, the whole point of this is that it's not just a calculator. You can do a whole bunch of cool stuff. So once you start assigning operators, once you start assigning objects, you can sequentially do more complicated things. So I'm taking my object, then I'm doubling it for some reason, and then I'm storing it as another one. So you can just keep going down the rabbit hole of doing things on objects. Okay. The important thing is you don't have to write sort of all of these from scratch. R has been developed for decades. So the point is that people have written functions to do things that are already relatively complicated, but are useful in general. So a really basic function is just the square root function. So this was written by some person a very long time ago and just exists in R's repository of things that are useful. So if you the basic structure of a function is you have whatever the function name is, and then within parentheses you have you're supplying arguments, and then you're setting them each argument to a certain value. Okay, so in this case, the root is my object, which you've already assigned as 1 plus 2, so it's doing the square root of 3, and it's producing that as your output. Okay, so basic functions. Which brings up an important thing, that when you are working with functions, they usually take certain object types. So for example, if you created something like my object, you can check what type that object is by using the class function. So this is sort of a meta function of checking sort of what objects are, sometimes useful if you're not sure what sort of another person has created in your R script or something. So if you run it through, if you supply it as your value to this class function, it'll spit out, okay, this is a numeric variable. Okay, and so a numeric is sometimes also referred to as a double. The bits and bobs of why a numeric is different from a double is not super important, but just know that both of them are basically just numbers to R. And so if you are working with a different set of information, so say you have a categorical variable in your data, you ask a bunch of people what they had for breakfast, and one person says apple, and you here you can see that in order to tell R that this is in fact a string or character variable, it has to be within these quotation marks. Otherwise, R will think that it is an object, right? So here I don't have any quotation marks, and I'm not supplying them up here either. So it looks for an object in the environment named exactly this. If I had dropped the quotation marks here, then it will look for an object that I previously stored as apple, right? So it would yell at me and say, there's something wrong, I can't find apple, what's going on? So the important thing is when you're working with characters and strings, you supply these quotation marks, and it says, oh, okay, this isn't an object, I'm getting new information that is text-based. Okay, and so when you check its class, it correctly identifies that this is a character. Okay. So obviously you can get a quick error when you start working with different class types that it doesn't like. So let's say you do that example, you supply apple as my object, and you try to pass it through square root, the function. You get this error going error in square root, my object, non-numeric argument to mathematical function. Fairly straightforward what's going on. I hope everyone can tell why you would throw this error, or at least this error explanation is one of the better, more clear explanations of what's going on. But if you, in case you aren't, something you can do is in that console in the bottom left, you can type a question mark and then the name of any given function in any given package. It will search through the compendium of R's repository down here in the bottom right, and it'll spit out like the actual documentation of whoever wrote square root decades ago. Like it will say exactly what they programmed and how they programmed it. So for example, if you do question mark square root, anyone could do this on their computer right now. It'll say something like this, usage square root x, and what the arguments, that x has to be a numeric or complex vector or array. So obviously this apple is not a numeric or complex vector, right? It is a character or string, so that's why it's yelling at you. Okay, so I strongly recommend when you're getting errors, not if, when you're getting errors, to check out the documentation, see if the syntax is being weird, if you're supplying a weird variable. This is the first line of defense. Okay, so that brings me to just generally when you're coding, the most useful thing you can ever do is learn to sort of comment liberally, comment as if you're going to lose your memory tomorrow, comment as if, you know, this is your Bible, because you're going to come back to the benefit of writing code is that you only have to ever write code once. If you write it well, then you can always come back to it. I'm going back to scripts that I wrote 10 years ago because I wrote it and I know what it does. And so I'll think, oh, I did it in this one study. I'm just going to go grab it and paste it into whatever new project I'm working on. So when you comment liberally, you can remember how something was working and why it was working. Give yourself that gift. So in order to comment, you just put this bound symbol. Any number of them works. It doesn't, as long as a single one is there, but extra ones just make it visually distinct because it's farther to the right. So any number of them you can put, and so it will recognize that this is no longer our code, even though it's within the chunk. So you can just write like a regular English sentence. And so I strongly recommend putting as many comments as possible. So say if you get an error, you can quickly write your comment, okay, I got this error, but I did this. And so you can explain sort of what's going on. So for your future self can look back, oh, I can't change that because I got an error last time. Okay. And also, this is going to be hard to explain, but in the script, basically everything outside of a chunk is non-functional. So if I put it past this fence and not sort of before the beginning of the next one, it's just markdown text. Like I said, it's Wikipedia article editing. You can just write whatever you feel like out there. And I strongly recommend writing as if it's a Wikipedia article, write as much as you want. It's always better to write more than to write less in comment-wise. Okay. Just to drive these bits home, again, comment as if your life depends on it. Try to describe why rather than the why. Any comment is better than nothing, but I'll give an example of the why in a second. The other thing that people never told me was that you can use comments to hide stuff instead of immediately deleting it. So I have friends who have different coding styles than me, I will say. And so they have frenetic energy. And when I tell them there's an error, like, oh, it's because of this line. And she deletes it. It's like, oh, it's gone forever. So you can just comment things out and then keep working. And then so if you find out that your first thing was, oh, it was kind of close, it's still there for you. Okay. The example of the why as opposed to what. Here, for example, this comment, convert my object to numeric and then square root it. That is exactly sort of what this line is doing. You're using the as numeric function on my object, which converts it to a numeric object, and then you're square rooting it. Cool. So this kind of comment is correct. But it's more of so that what question. It technically is just translating exactly what this line does. It's better than nothing, but sometimes when you are learning to code, the better practice is to explain more of a why. So square root only accepts numeric objects. That explains more than the original one, which is actually technically redundant with the code here. So just a little plug for that. Okay, so any questions about, and feel free to like ask questions throughout as well. I should have said that at the beginning. Okay. So the vast majority of data that you're working with are in tabular format, so rows and columns. The lingo for it in R is called a data frame, and basically it's something that you should be familiar with if you're with like Excel or anything. Then it's just you have variable names in the first. Well, technically, it's not a row. You have the variable names up here at the top, and then as you begin going down the rows, you have observations. So, for example, the cheetah, and this is just a default data set. It's fun. It's different animals, and they're like how much they sleep, how big their brain is. It's just so when you're working with data, they are generally stored in the environment as data frames, and you can inspect them by clicking on them in the top right, and it'll just launch exactly like an Excel spreadsheet. Okay. Oh yeah, and you can also use the help function. So we're going to talk about the basic ways of like interacting with data, and so we would call this like data wrangling of how do you get data into the shapes that you want or create new variables. All of this is sort of how you would sort of manipulate your data into something that is useful and analytically available. Okay. So in base R, you may have seen people using the square brackets or this $ symbol, and that's totally fine. Like these are functional, but actually I'm going to skip over how to do this because I feel like it's actually a little bit more educational to talk about something that's called the tidyverse. So if you're familiar with this, by all means, keep using it and it's useful, but ask me questions later if you want to hear about that. The more educational thing, I think, is actually starting with the tidyverse, which is basically a very well-known collection of packages that makes life very easy in R. So it's not a default thing. You do have to like load and download this, but it's the point of it is that it makes things very logical in terms of, oh, I know pretty much exactly what it's doing, as opposed to these square brackets can be a little hard to interpret. So when you are trying to subset, so select like a certain amount of your data, like I only want, let's say I'm only interested in carnivores and they have to be, they have to have over 20% of their brain weight is, I think there's also like an actual body weight or something. So it needs to be 20% of their body weight or something. So that's a basic like subsetting problem of I need to select certain variables and certain values among them, right? So the way you do this is two core functions, which are filtering and selecting. And the way that I keep them straight in my head, or at least when I started learning, is that filter ends with an R. You're grabbing rows, okay? Select has C in it, you're grabbing columns. I don't know if that'll be helpful for anybody else, but that was how I got them straight in my head, because technically both of them are not semantically meaningful. You can filter and select in any direction. But when you're selecting, you're choosing certain columns that meet a condition. When you're filtering, you're selecting certain rows that meet a condition. Okay, so I did the opposite. Let's say I'm grabbing only herbivores. In this case, I mentioned, so there's this vor column here. And so it's listed whether it's a herbivore, omnivore, carnivore, or not applicable, so it's missing data. You can use this whole filter thing to grab certain rows that meet the condition, right? So logically, what you're telling R is keep only those rows where vor is equal to herbivore, right? So how you would execute that is just using the filter function. You input the data frame as the first argument, and then the second argument here has to be whatever condition you're meeting. So in this case, use this double equals in order to tell R you're looking for an equality. So I want only examples where the left-hand side is equal to the right-hand side. If you used one equal sign, you would actually be assigning it's an assignment operator, like the left-hand error. So you would be creating an object named for and then assigning it herba. So make sure when you're actually testing equality, like I want left side equal to right side, you're using the double equals R. But when you do this, it's pretty quick. It just grabs you. Okay, so I'll look through this data frame. I will look through the column 4 and only select ones that have this herba value. And there we go. So it spits out exactly what you want, just the herbivores. Okay. A very similar thing. Once you have the gist of it, of this filter function, you can apply the same thing to selecting. So let's say I only want sleep-related variables. You'll see that there's a bunch of variables here that start with sleep, and I don't care about anything else in the data set. So what I do is, again, keep only columns, and you can actually combine it with a couple of really useful tidyverse functions, starting with sleep. So how you do this, very similar thing as the first argument, you're putting in the name of the data frame. And then here, everything else that you're supplying are all conditions that it's trying to meet. In this case, you separate each of the different arguments using commas. So first argument is just the name of the data frame that you're selecting from, and everything else after it is a condition that it's trying to meet. So I'd like to keep the name of the species. I'd like to keep whether it's a herbivore, carnivore, all that, and then all the sleep variables. And this is, again, a logical thing from tidyverse that is weirdly difficult in base R. The tidyverse lets you just say, okay, I only want things that start with. You can also do ends with, you can do contains, matches. There's a whole number of different selecting functions that are very easy to work with, very logical. So I strongly recommend looking into those. But say just starts with, and then I have those quotation marks because if it was just sleep, it would look for an object named sleep. And sure enough, you can grab all of those. Okay, I'm going to skip a couple of things ahead just so you get a little exercise. So we just talked about this filter and the select function. We'll jump back in a second. I'm curious if we can figure out a quick exercise. So we have 4 options here: option A, option B, option C, and option D. Just for your reference, I put the correct functions that we just talked about. So the ones that work: filter, and sleep, and looking for herbivores, and then this select function where we want all the variables that start with the word sleep. Okay, so these are correct. These are correct. Out of option A, B, C, and D, which one is correct here? So which option works, doesn't throw an error? I'll give you some time. Feel free to ask me any questions if you are unsure. We'll give you a minute to think about it. Right. Thoughts? We can just do hands up if people feel comfortable with it. I don't want to put people at ease. So option A, okay, one person. Option B, nobody. Option C, okay, and option D. Okay, seems like the majority is D, and I will say it is D. D is correct. So usually when people see this, people usually immediately, I don't know if anybody got like an instinct that C seemed immediately like most correct. But if you look at the other options, they're actually both basically exactly the same thing, just all nested together. It's hard to see because of how it's structured, and I'll explain how you would fix this in a second. But basically, if you cross your eyes a little bit, so let's see the correct examples here. Filter, sleep, that's all. You can copy and paste it, set it right here, right? That's the first bit. And you're supplying that as, whatever the output of this. So the filtered data set that only includes herbivores is now being pushed into the select function, right? So I only have herbivores in this weird data frame. Then I'm selecting name vor and only the things that have sleep. So it's technically correct. It's doing exactly the same thing as this, except it's the M sleep that you're supplying has already been filtered. Okay. Exact same thing can be applied here. You're doing that selecting step first. You're only grabbing it's the exact same thing as up here. And then you're applying the filter function after it. You've just supplied the pre-selected data frame first as your first argument. Okay. This one is usually what people have a gut instinct of is correct first, because it does the same thing, just visually is a lot easier to parse because you're doing that filter thing, you're supplying it, and then you're storing it as this object, df filtered, which is technically exactly what it's doing here, but split into two different steps. Right? And then you're selecting after. So technically all of these work, but clearly one of them seems more visually interesting. I'm glad most of you did pick D. So that brings me to this important point of, when you're doing this kind of stuff and you're like nesting a whole bunch of things all together, it works, it's clearly correct, right? But it's very hard to parse. It takes a long time to figure out what's going on. You can visually change things. So basically, I strongly recommend letting your code breathe is what it's called, of like you add in a lot of line breaks. R doesn't care if there's a break here. It does the exact same thing because it's kept together by the parentheses. So you can actually split it here. Maybe now it's more visually obvious. Oh, okay, this filter bit is correct. And so it's just selecting after. But the real way, I think, anybody who's currently working with R would actually recommend doing is using pipe notation instead. So instead of nesting things in a backwards way that's hard to read, you can actually just go in a logical step-by-step function, and I'll explain what these things are. So this percent greater than percent. I always forget which one's which. This is what is called a pipe in our language. So this is, you might see actually, they've just started a base version with that is just like a straight line and then a greater than. So you might see those as well. But because it's an active development, I didn't put it here. It basically works exactly the same. So if you see it, it's the same. But this bit is what we call a pipe because what it does is it passes whatever is here into the next thing that you're supplying on the line down. Okay, so whatever is here. So for example, I just call msleep, just print the data frame for me, please. Okay, then if I put a pipe here, it means, okay, I'm not done with you. Can you please, I push whatever the output is of this code on the left here, push it to be the first argument that I'm supplying into the next line. So what this functionally does is msleep, it gets pushed to become filter msleep, comma, vor equals herba. Okay, so if this pipe is dumping it as the first argument on the next line. Okay, and then you can keep doing that on and on, where I've put a new pipe continuing in it, where after you filter that to only include herbivores, I'm again dumping it into this select function. It now becomes select comma, everything that happened before it. Okay, does that make sense? It's being dumped as the first argument onto the next line. Whatever the output is sequentially is being passed on to the next one. And the reason why that's helpful, I'll ignore that for a second. The reason why this is helpful is I hope you can see that this is much easier to read. Just visually, you can see, okay, step 1, I'm taking this data frame. Step 2, I'm filtering it. Step 3, I'm selecting something from that new filtered data frame, right? You can just read it like a human would. This does the exact same thing, but technically because of the way that we're stuffing things into functions, it's actually all backwards. Select is the last step, but it's the first because you're stuffing things into the different functions. So here, when you look at it, you actually have to work backwards of, the end step is selecting, then the one before it is filter, and then the one even at the start is this msleep function. So I strongly recommend starting with pipes because it will have really, it will change the way you code visually, and so you don't need to. This is not an educational step of your R code. Like, this doesn't benefit you starting at it. So that's why all of this is so helpful. Okay, any quick questions about this, or we'll have more examples in a moment. Okay, awesome. Should we go back? Okay, so I'm going to go back for a second before I forget, and just a quick break into more sort of, this is the actual technical term is called code smells, which is hilarious to me because it implies that your code is stinky. So your code can be functional and correct, right? It can do perfectly exactly what you want it to do, but a code smell is like when something is, repetitive or functionally slow or is hard to understand. So one of the really important things I want to instill, hopefully at the start, is to pick a naming convention. Most people, when they're starting, will just sort of name things however they're feeling at the time. It honestly does not matter which one you pick. The only one I actually don't recommend is the kebab case, because in R, it really does not like hyphens. That's the one thing that it yells at you for. But pick whatever you visually like and stick to it. It really doesn't matter what, but please, please, please pick one, because then you'll just know sort of what your variable names are. A code smell would be if like half of my variables are in snake case and then a whole bunch are in camel case. And then when I'm trying to subset later, I don't know, I can't, I'll show you the example. If I try to subset and a grab like starts with sleep, yay, all of these are in a logical way. But if I wrote this the way a human would, they would probably say just like total sleep, REM sleep, sleep cycle. I suddenly can't use this anymore, right? So sometimes you have to write things in a way that is human, like less obvious, to make it machine readable. Okay? Theoretically, you could technically still use this contains bit, but let's say someone did something truly outrageous and just like named things in a weird way, you really have no recourse of being able to select things. And so it's just code smells exist. Think about sort of how you would work with it as a machine. And there's some good resources as to how you can avoid these problems early on. Did I skip anything else? Okay. So back to pipes for a second. So here we are. So another benefit of using pipes, besides being like easy to read and understand, is that you can actually, so I talked about comments. You can comment out little pieces of the pipe, right? As long as you sort of, so let's say your supervisor comes to you and says, you've done your analysis, and your supervisor says, well, actually, the whole herbivore thing, that doesn't matter anymore. That's silly. Let's not do that. If you are working with your sort of nested function, good luck. You have to sort of go in and like cut out bits and pieces and hope you don't break your code. But if it's in pipes, you say, okay, no problem, supervisor. I'm just going to comment out this one bit that is doing the filtering and click run again. Done. So pipes help the way that chunks help, in that you can select out little bits of it and say, I don't need that anymore. I don't want it part of my pipeline. And you can just comment it out and it's gone. Right. So I've commented out the herbivore section, and now it's doing the exact same thing. Everything else in my pipeline, except it's bumping out the one line that told it to do that thing that is no longer useful. So strongly recommend. It's super helpful to do this kind of thing. Okay, and a little quiz also for how pipes work. So we have, again, 4 options. We're going to try to find which one does not throw an error. Okay, so I'll give you a little bit more time, but yeah, maybe I'll just say, again, just as a reminder, what the pipe means is it's dumping it as the first argument in whatever's happening next. Okay, see if you can spot any issues. All right, how about these? So yes, most of these are purposely a little ugly. Otherwise, it's a bit too easy. So who here thinks A is the correct one? Will not throw an error. Okay, A. A couple of people. There's like 4 or 5. How about option B? Option B, less popular for one person. Option C, nobody. Okay, option D. 2, 3, 4. Yeah, like the so the correct answer, I believe, is D. So congrats. Most of the class again got that, but this one is a little tougher because, again, hard to see things. But the reason why, let's say, option A fails is, let's see. So if you dump msleep in here, and then it's already filter. Yeah, this bit includes the msleep sort of data frame. So if you supply it here, it actually bumps this off of being the first argument anymore. So it would throw you an error. I'm selecting on a data frame. Why are you giving me another data frame as my second argument? Got it? Similar thing happens here. So you would filter for, well, different issue. Does anybody see what the problem is here? Yeah. Sorry? Yeah, exactly. Perfect. So you're missing the data frame. It's trying, you're supplying it the condition, but it's missing a data frame, and when you pass it. So actually, this error has nothing to do with the pipe. It starts with something that is unuseful. Awesome. And then C, this one's a fun one. I'm glad nobody, usually this is the one that people select as correct. So I'm glad people noticed it. So does anybody have any comments as to why they did not pick this one? Yeah. Yay! Yeah. Okay. I constantly have to when people are asking me why is my code not working, it's usually this kind of thing of like, oh, so when you put a pipe at the end, so everything else technically is correct here, but the pipe at the end says, I'm not done with you, keep going. So if you run this, it'll throw you an error saying, what's next? I'm looking for the next thing. So it can be a lot of little simple things like this of just check that you've actually ended your pipeline, because sometimes I will just do that. I will just keep putting pipes and then what's going on? Okay, so technically none of these work, even though C is quite close. Awesome, good job. Okay, the other bread and butter thing besides subsetting is usually mutating. I had my PhD supervisor, when I told her about like she doesn't code at all. So I said, oh, I'll just mutate it. She's like, oh, that sounds like a scary thing. Why would you do that? Why would you mutate your data? So it's I don't know. I don't think it has a negative connotation, does it? Anyways, basically, anytime you want to create a new variable, you can also technically overwrite variables with mutate. So if you want to create something that doesn't exist in your data, which is almost always, so you're just doing some kind of transformation, you would mutate. So let's say you want the amount of non-REM sleep. So here we have a variable that is total sleep, the amount they sleep, and the total REM. So obviously the amount that is not REM is this is rem subtracted from total, right? So how would you do that? You have to make a new variable, right? You just have to subtract sleep rem from sleep total. And so the way to do that is using this mutate variable. Okay, so it's very similar now that you know the structure of how filtering and subsetting works. So you take again, start with the data frame, whatever you contains the data you're interested in. You mutate, and then the first thing that you're supplying is this is the name of the new variable you want to create. It can be anything, just like you're assigning a new object, right? It can be anything that you think is meaningful. And the important thing is because you're assigning it to this new variable, it actually is the one equal sign, not the double equals, because you're not testing whether left is equal to right. So new variable name, and then you tell it, okay, this new variable I want to be equal to, and then you have your whatever math you want to apply. Yeah. Yeah, I don't know. I think it's just so it will, I'm like 99% sure, throw an error if you put the like arrow in there. It's because it's so you could technically use this single equals outside of like this pipe and it'll work, but people visually like to keep them distinct when you're working like within sort of functions to like use the single one when you're like inside of a function, whereas if you're assigning objects in sort of the outside world, people generally prefer using the arrow. I'm not sure why, it's just convention, but specifically it will throw an error if you try to use it because they built the function using these single equals in mind. But it's similar to like if you're using like Python and stuff like that, when you're like argument equals value. So think of it like that when you're inside of a function. When you're assigning objects outside of a like pipe like this, then yeah, you'd use the arrow. A good question. Okay, great. And then, yeah, so once you create new variables like that, sleep and REM, you can do, again, anything you want to the new, it'll just create a new column named this, and then you can do exactly what you want with it. So I just want to grab the sleep ones, and there you go. You now have this new variable, including anything you want. And again, it doesn't have to be like simple arithmetic. You can do all sorts of incredible things. It's just straight R code, whatever you want to put out there. Okay. Awesome. One of the ways that's fun, if you want to code along, is the easiest way to start learning, honestly, is with data visualization because you get like immediate feedback of what you're doing. So you can make pretty plots in R. We don't have time to talk about like what ggplot and stuff like that are, but strongly recommend. I bring up this because ggplot does so. This specific function, it's a plotting one, and it does not like when you just dump like a data frame at the start. It doesn't recognize what it is. So it needs to be told that the argument here is data and the value I'm supplying is the data frame. So this is an example of one place where you wouldn't actually, so the default is always like stuffing it here, but it doesn't, you wouldn't be able to tell it, data equals this. It doesn't know by default. So sometimes you do actually need to point a specific place. So when you want to supply it as one specific variable, to one specific argument within the function, then you would use this dot operator, telling it, okay, msleep, instead of its default activity, which is to put at the start, actually put it at the end where I can tell it, okay, this is the data that you're working with. So just in case you see that, that's what the dot means. It's you're supplying the piped object just somewhere else in the pipe, not at the start. Okay, so one of the magical things about R when you start working with it is that you can render or knit stuff. And this like blew my mind when I started working with R. It's really honestly one of the huge upsides of it because it's completely like self-contained and you can just send it to your supervisor or a collaborator and just like, here's all the code. You can see it. Here's all the data. You can inspect it. I don't need to like explain where my data are or how many subjects are. It's all there. So what it means when you click this button, it'll render for QMDs and then knit for RMDs. But the point is when you click it, it spits out a .html file at the end. Okay, you click it, it runs all the way, assuming you get no errors. It will just spit out an HTML file where your R project is. Okay, so that file will just look like you can inspect in the example code that I gave. It will have, for example, you can just click through and say, oh, this is the data set that they're working with. I can see that there's cheetahs in here and owl monkeys. So huge upside of working with this kind of stuff, because when you're working with SPSS PDFs, it's a lot of like version control within version control. So these are super helpful. Okay. So final thing about warning about sort of when you're working with our R, and so the environment that I talked about in the top right, I already mentioned the whole clashing issue if you don't have an R project. If you just sort of load everything into the same global environment, you'll just be like creating more and more imaginary objects that can potentially, mix up your different data. So one tip that I do recommend as at the very start is do not, like, it'll ask every time you close R Studio, do you want to save whatever's in the environment? And it's fine, like it's not going to do anything harmful, but a good practice at the start is just to not ever save anything. I know people get a little anxious about that. And I tell my friends, they're like, no, I need it. What if it breaks? And like, I need this thing that I was working on, and like, I don't want to have to regenerate it. But the point is that when you restart the code project, it should run from the start without any problems, because if you just save that environment and just assume that your code is working, a year from now, that code could actually have an issue with it. And because you just kept saving the environment, you didn't realize that there was an error producing that object. So I strongly recommend not saving the environment. It does mean you have to regenerate things from the start, but that is a good practice to get into the habit of early, because it should run fresh from the start without any issues anyways. So if you just rely on an environment that you get saved, so it will actually produce a .r data file. That's the kind of thing you would ignore. So if you had sensitive data, that's the kind of thing that you would put in your .ignore. But generally, I recommend not saving and starting from fresh every time. Okay. The other thing, I'm happy to talk about any of these, but there are a lot of, half of the fun of R is learning a new package. And so these are like incredibly useful for me. I use them every time. I can explain basically what any of those does. The main one that I talked about today is just the tidyverse. So strongly recommend, even if you're just starting, don't bother necessarily like learning all of the base R things. If you just start with tidyverse, it's a huge leg up. There are things that are just packages that I can't live without, and happy to explain. As I mentioned, R is like being totally open source means that a lot of people just like make resources for free because they want to give back to the community. So all of these are free. The first one is I actually also recommend because it's an entire like course. It's self-paced, so you can just work through it on your own. But yeah, it's an entire course teaching people how to work with R. So yeah. Oh yeah, also, I do take questions. So, this is my permission that if you have a question about R and stuff like that, please do just email me. I can't, I am not sort of annoyed by questions about R. Okay, I think that's my last slide. Yep, 53 and 53. Any questions? Hey, thanks very much. And I hope that was useful. Ruchi is going to be doing PLS, partial least squares. So you'll be able to do sort of an actual thing with R. So I'll be looking forward to it. Thanks. stop the recording on this side, or should do I stop recording you? Or, oh, okay, thanks.